Hi everyone, welcome to DMR tutorials. Today in this capsule we'll discuss about the graphs of motion. So when a body is in motion, related to that body we can represent the motion of the body graphically. There are basically two types of graphs we are going to discuss. One is displacement time graph and the second one is velocity time graph. Displacement time graph, short form is ST graph, velocity time graph is VT graph. Now let us see first about the displacement time graph, ST graphs. Take the time of journey on x-axis and the corresponding displacement on y-axis, and if you plot the points and draw the graph, and that particular graph is called displacement time or ST graph. Let us see, by looking into the shape of the graph, we can find the nature of motion. In what way the body is moving, that you can find by observing the shape of the graph. Let us see the first in the list, example 1. Let's see the situation here. Time, displacement. Suppose this is the point of reference O, and here this is the initial position of a body P, and the distance between these two is say 5 meters. So initially at 0 time the displacement is 5 meters, and after 5 seconds I observed I could not find any change in the displacement, the same 5 meters. 10 seconds also, same 5 meters. 15 seconds also, same 5 meters. So, as the time interval is increasing, but I cannot observe any change in the displacement or any change in the position of the body. And the graph will be like this. X-axis, y-axis, here it is time and it is displacement. Time in seconds, displacement in meters. 5, 10, 15, 20, here also 5, 10, 15, 20. First point is 0, 5. On x-axis 0, y-axis 5, this is the point. 5, 5, x-axis 5, y-axis also 5. 10, 5, x-axis 10, y-axis again 5. 15, 5, 15, 5. And if you join all these 4 points, you will be getting a straight line which is parallel to the x-axis. So in a ST graph, if the graph is parallel to x-axis, that indicates that the object or the body is in the state of rest. So parallel to x-axis, then the object is in the state of rest. So whenever you see any ST graph, if at all it is parallel to x-axis, then the ultimate conclusion is the body is in the state of rest. That means the body is not in the motion. This is the first example. And let us see the second situation, B. The same situation, first is time, displacement. When time is 0, displacement is also 0. That means O is the point of reference and the object P is also at O. The object P is also at O initially. That means initially the displacement is 0. After 5 seconds, it was observed that the body is moving in this direction. It was observed that the body displaced through 5 meters. After 10 seconds, say it is displaced to 10 meters. After 15 seconds, say it is displaced to 15 meters. That means as time is increasing, the displacement is also increasing. As time is increasing, the displacement of the body is also continuously increasing. 0 to 5, 5 to 10, 10 to 15, like that. Let us see the graph of this. As usual, x-axis, y-axis, origin, displacement and time. 5, 10, 15, 20. 5 meters, 10 meters, 15 meters, 20 meters, like this. Now first point is 0, 0. 0, 0 is nothing but origin. So the graph is started from origin. 5, 5. Time is 5, displacement is also 5. 10, 10. Time is 10, displacement is also 10. 15, 15. Time is 15 seconds, displacement is also 15 seconds. If you join all these 4 points, you will get a straight line. So, if the ST graph is a straight line, inclined in the positive direction with x-axis, then the body is said to be moving with a uniform velocity. The body is said to be moving with uniform velocity. So, this is about the graph. So, this is the displacement graph and it is example 2. Now, let us move on to the third example of ST graph. As usual, time, displacement. In the starting, when time is 0, say displacement is also 0. After 5 seconds, 5 meters. After 10 seconds, 15 meters. After 15 seconds, 35 meters. So this is the table given to you. So initially, the position of the object and the point of reference are very close, so displacement is 0. After 5 seconds, the body displaced by 5 meters. After 10 seconds, 15 meters. 15 seconds, 35 meters. Let us plot a graph related to this table. The graph, x-axis, y-axis, time, displacement, 5, 10, 15, 20, 25, here also 5, 10, 15, 20, 25, 30 and finally 35. Now let us plot the points. 0, 0 is the origin. 5, 5. Here it is 5, 5. 10, 15. 10, 15. 15, 35. And if you join all these points, you will get a curve like this. It is not a straight line, it is a curve elevated in the upward direction. This indicates that if you see ST graph in this shape, that gives you the information that the object, the body, is moving with a non-uniform velocity. So whenever ST graph is a curved line, then it says that the body is moving with non-uniform velocity. So we have discussed three things: parallel to x-axis, body in the state of rest; straight line, the body is moving with uniform velocity; curved line, the body is moving with non-uniform velocity. These three are the different situations of displacement time graphs. And that's it for this capsule displacement time graph. Next capsule will be velocity time graph. We will see in the next video.